Hello, Clay here again. So what I want to do here is kind of run through how this optimal calcs works and also demonstrate how to get the values with my Python code and also what it looks like in Motec. For some reason that I have yet to figure out, which is my next project, the values that I get from this built-in calculator that I coded a while back is giving me quite different results from my Python code. But my Python code gives results that pretty much match exactly what you see in Motec. So I have to kind of try and figure out whether I've got a C# library difference between the Python libraries and that's accounting for the error or what, I don't know. But at any rate, I'll show you the routine here for learning the optimal shift RPMs using this calculator. And while that's being done, we'll also be recording some telemetry that we can use with both the Python code, which is included with SoundShift, and with Motec. So first we'll run through this. I've got some values here already, but I want to start over, so I'll hit reset target RPMs, and that will reset all these target RPMs in the left side there. And I'll put a check mark in optimal calcs, and now it's ready to start watching acceleration runs in each gear, gathering the data it needs. So what I will do here is in each gear I will run at full throttle right up until I hit the limiter, then I'll let off the throttle. And then once it's coasted down a little bit, I'll shift into the next gear, and then I'll slow down a reasonable amount and do the acceleration run in the next gear, and then I'll do that for each gear. And you can see each gear is turning green once it's learned. That time it wasn't quite the limiter, but it's enough. Usually you want to go right to the limiter, but in fifth gear there it's kind of tough to do. As long as it goes green, it's fine. And then in top gear, I just want to make sure I go faster than I was going in the last gear. And that's already there, so that's good. Okay, so now we have some target RPMs automatically populated here. and that's from the calculator, and you can see it automatically turns itself off. Each of the gears were successfully learned, so they turned green, and these have been updated with what it thinks all the crossover points were between each gear. But I can tell you already those are incorrect just because I know what this car needs. So first let's look at the optimal shift points Python code. This actually comes with SoundShift, but it needs to be in the telemetry folder. And where are we here? So this is the telemetry that was just recorded, and it'll actually run on all the telemetry files that it sees, but since we only have the one, we'll only get the answer for one there. So we'll just double click that, it'll run, and then we'll have a graph after it's finished. And this graph shows the acceleration curve for every gear. And the dotted lines are to help deal with the noise. You can see this isn't a very smooth curve on its own, but the dotted line through it is a lot smoother, and the dotted line through it is what it actually uses for calculating where each of these crossover points happened. And each of these crossover points represents where the acceleration from the current gear is becoming less than what you would have in the next gear. So what that means is each of these crossover points is where you would want to shift. And that's what all these values on the upper right of the graph show you. And they show you where those crossover points are happening, at least as far as that algorithm is concerned. But as you can see, even though I have code that, at least so far as I can tell, is very, very, very similar to what I'm doing in the Python, but I'm getting quite different answers, and I'm not sure exactly why. So that's my next project, is to kind of get these two to agree. And the reason I think this Python code answer is correct is because of what I'll show you here in Motec. I load that up in Motec here and make sure it's looking at all of the data. And you can see similar output. We've got a graph with the longitudinal acceleration versus ground speed, which is the same as what you see in the graph from the Python code. Acceleration here, speed here. The nice thing about doing this in Motec is if you hold down your mouse button while you're dragging the mouse around, it snaps to whatever's closest. So you can see in the lower right here the RPM, and the crossover point is somewhere near here, obviously. The RPM that we're getting at this first first spot that they touch is 74.88, 74.75. So really close to 74.90, and then where it's kind of obviously crossed over now is 76. What did we get in the 75.70 was our answer from the Python. Here's 75.70 here. See, so I would kind of think that that answer is correct. Get for the next one, 7400. Along gear 2, where it crosses over. And once it gets to the spot where it crosses over, you've got the mouse button held down, it kind of starts snapping in between each gear. So you'll see the RPM 73.99, 74.01, and 60.61, because that's gone to the next gear, obviously. 2, 3, gear 2, gear 3. So 74.01, got 7400 there, and I round this a little bit, so that is another correct answer. Gear 3, we got 7320. We got 73 there, 72.99, but it is, you can see there's a little bit of noise, right? So we have to account for that. So we'll be rounding a little bit. So 72.99 is where that showed crossing. $73.20 was our answer here. Now, since this data is smoothed a little bit, that $73.20 is probably closer to the truth. $72.10 for the next gear. And you can see the green, the dark green line is very noisy compared to the light green line. What did I say? My short-term memory's gone. 72.10. Kind of first starts crossing over around 71. Yeah, and then around there, sort of, it becomes more obvious. Again, I would say this answer is good to take. 72.10. 72.80 for 5th to 6th. You can see how noisy the dark green and the yellow are too. So, to me, those answers look right. So what I will be doing for the next, hopefully not 9 months, is trying to figure out how to get this answer directly in SoundShift to agree with my Python code. And whenever I get that working better or identically, hopefully, then I'll release an update for that as well. But in the meantime, yeah, just record some telemetry like that and use the optimal shift points that comes with SoundShift. Just put it in your telemetry folder after you have recorded some of that telemetry and run it. Just double click it and it'll spit out a graph like that. And these numbers that it gives you, as long as your telemetry was decent, the numbers are, you can trust those pretty much. Alrighty, that's it for now. Have a good one.